In this session, we are going to talk about operators. So we keep on performing several calculations, mathematical, non-mathematical, in our program. So let's say whether I have to add two numbers, or I have to find whether two numbers are equal. Let's say I have to take about the equality, or whether two numbers are greater than equal to, or for that matter I have to find that whether a particular condition is true. The condition could be anything. So we have to perform lots of operations while we are writing a program, and for supporting these operations we have several operators in C++. So now today we are going to talk about these operators. So if we broadly classify the operators, the classification goes like this. We have few arithmetic operators, we have relational operators, we have logical operators, we have bitwise operators, and we have few other operators as well that we will talk about. So these are four broadly classified operators that we have. Apart from these four, we have other operators as well. We will talk about few of them also. So if I talk about arithmetic operator first, so arithmetic operator helps us in doing all the mathematical calculations. So just like we have in maths, we have plus, minus, division, multiplication, and remainder. So this is something new which you might not be knowing in case you're learning programming for the first time. So we will talk about all of these operators one by one. So this was about arithmetic operators. In relational operator, we generally do comparison. So relational operator generally supports comparison. As I said that we have to check whether two numbers are equal to or not, greater than, less than, what is the scenario. So the operators that come inside relational are greater than, less than, equal to, not equal to, greater than equal to, and less than equal to. We will talk about each of them one by one. Logical operators are something which generally give the output as true or false. So the operators that we have in logical is logical and, logical or, and logical not. We will talk about each of them. And then we have bitwise operators. Bitwise operator is something that performs operation bit by bit. So the bitwise operators that we have and, bitwise or, ones complement. This is right shift and this is left shift. Now let's try to understand each of these operators. Apart from these operators, two operators that we will talk about here is that size of operator and a ternary operator. So after we have discussed these, we will talk about these two as well. And we also have some assignment operators. We will talk about these assignment operators as well. So after we have discussed each of these operators, we will talk about size of ternary and assignment operator. So let's go on to talk about each of the arithmetic operators now. Coming back to arithmetic operators, apart from these operators, we also have increment and decrement operators. So we will talk about these as well. Before discussing each operators one by one, we need to discuss one more thing. So we saw that the operators are classified broadly as logical operator, arithmetic operator, so based on the work that that particular operator is performing. So we also have a classification which I can say is based on the number of operands that an operator needs. So we generally have ternary operator, binary operator, and unary operator. So if I'm doing something like A plus B, this is the operator, and these are the A and B are the operands. And this is based on the how many operands a particular operator needs. So in this case, addition needs two operators. So I'll say this is a binary operator. So ternary operator is generally operators which work on three operands. So here we have conditional operator, which we are going to talk about. Let's say conditional operator. For binary operator is something that needs two operands. So we have plus, minus, multiplication, modulo, division. These are the binary operators. We also have a logical and, or as the binary operator. So as we go on to talk about the operators, we'll see whether they are ternary, binary, or unary. We are just having the definition of these operators here. So the unary is something that works on one operand. So taking some of the examples, we have increment, decrement operators, logical not, ones complement. So these are few of the unary operators. So again repeating, based on the number of operands a particular operator is using, we have this classification. Now let's go on to talk about arithmetic operators. So now we will talk about the arithmetic operators. So the operators that we had was plus, minus, or you can say addition, subtraction, division, modulo, and multiplication. This is called as modulo operator. Let's say someone asks you to write a program to add two numbers. So you can add two numbers using this operator. So let's say you have to do something like int sum equal to a plus b. So if the value of a is, let's say, 3 and the value of b is 4, you get the value of sum as 7. So this is the task of addition operator. Coming back to subtraction, so if we do something like int diff equal to a minus b, let's say a is 4, b is 3, we get diff equal to 1. We will talk about division and modulo. First, let's talk about multiplication. Again, the multiplication is same multiplication that we use in maths. So if someone writes something like this, int mul equal to a into b, if a is 4, b is 3, we get the value of mul as 12. So these are addition, subtraction, and multiplication operators, which are quite same as that we have maths. Now talking about division and modulo. So let's say I have a number 55, and if I divide 55 by, let's say, 10. So let's do the simple calculation. If I divide 55 by 10, I'll get 10 fives are 50, and I get 5 as remainder. So I really want you to see this part because many of the students get confused here in between division and modulo. So if you divide 55 by 10, you get 5 as the what we call as quotient, and we get this 5 as the remainder. So I think the 5 and 5 will get confused. So let me take 56. So let me take 56 divided by 10. We get 5 as quotient, and we get 6 as remainder. So let's say you do something like this. Int div equal a by b. Let's say our a is 55 and our b is 10. And if you do int rim equal a mod b. So if you do something like this in your program, int div equal to a divided by b, if you use this operator, this is the division operator, then what happens is that you get this particular value as the result. And if you try to print div, the value of div will come out to be the value of question. So here if you print div comes out to be 5. Okay, now here we have a mod b. So if the value of a is, let's say the value of a is again 55, b is 10. If you do use the modulo operator, what you get is the remainder. Make sure that once you get the remainder which cannot be further divided. So what students generally do is that what they do is that if they have to do this manually, they will put a point here and they will start dividing again. So don't put a point. So if you're dividing, the moment you get a remainder which cannot be further divided in an integer form, this will be your remainder. Stop there. And this remainder is something which you get as a resultant of a modulo b. So if you do a modulo b and you put the value in rem, you get the value of rem as 6. So need to understand that division gives me this particular value and modulo gives me the remainder. So whenever you have a question that find the remainder of a number when divided by this or that, whenever you have to find a remainder, you will use the modulo operator. And whenever you have to divide a number and get the quotient, you use the division operator. So these are few of the arithmetic operators that we have. Plus, or let's say addition, subtraction, division, modulo or remainder, and multiplication. So now we are going to talk about increment and decrement operators. So if we try to see that how do we use these operators, so if I try to see the syntax, so let's say we have x equal to 1. I can use increment in two ways. We can do either x plus plus. So plus plus is the increment operator and minus minus is the decrement operator. So we have two plus signs and two minus signs. So if I try to see about increment, I can use increment in two ways. First, x plus plus, and then we have plus plus x. We will talk about the difference. Similar is the case with decrement. So I can use decrement either as x minus minus or minus minus x. This is something that we called as postfix increment operator, and this is known as prefix increment operator. Again, this is postfix, this is prefix. So now if you ask that what is the difference between the two, so the very first visible difference is that in this case these increment operators are coming after the variable. Here the increment operator is coming before the variable. Same is the case here. The decrement operator is coming after the variable, and here decrement operator is coming before the variable. This is postfix and this is prefix. Now let's first see what does increment do or decrement do. So what increment does is, if you do x plus plus or plus plus x, in either case it increases the value of x by 1, and in case of decrement it decreases the value of x by 1. So in both the cases the value of x is getting incremented by 1 in case of increment and is getting decremented by 1 in case of decrement. So let's say I write a code in which, let's say I have a main function. I simply write x plus plus and I go on to print this value of x. So if I write cout x, here I do x minus minus and I go on to print the value of x. So in this case my x was 1. After incrementing by 1 I get the value as 2. In this case I get the value as 0. Now let's see several scenarios to understand the difference between postfix and prefix. Just to repeat, increment increases the value by 1 and decrement decreases the value by 1. So plus plus is 1. So I can say that x plus plus is equivalent to x plus 1 and x minus minus is equivalent to x minus 1. So in both the cases, x plus plus or plus plus x is equal to x plus 1. X minus minus or minus minus x is equivalent to x minus 1. Let's now see the difference between postfix and prefix using some examples. So we have several programs here. Let's see the output of these and then we will understand the prefix versus postfix. So here my x is equal to 5. I am incrementing x and assigning the value to x. Then I'm again incrementing x, assigning the value to y. And I'm printing x and y. So in this case, if I print x and y, first I want you to solve by yourself. And then come on to see the solution. I am discussing the solution now. So here my x will be 7 and my y will be 6. We will see how. In this case again we are using pre-increment operator, a prefix operator. So here I am first printing x here. Here the value of x will be 6 and my value of y will be 7. So here my x is 6, y is 7. And when I'm again printing x, my x will be 7. Here I'm printing x and my x will be 6. Let's see what's happening here. So what happens in postfix is, first the original value is returned and then increment operator is performed. In case of prefix, the value is updated with the increment operation and then the value is returned. So here I can say like this, that first original value is returned, or I can say is evaluated or used, and then value gets updated with the increment operation. So we are discussing increment here. So we are discussing between postfix increment and prefix increment here. Decrement, postfix and prefix will have the same concept. It's just that there it's not getting incremented, it's getting decremented. So here we're trying to understand postfix and prefix increment. So first original value is returned and then value gets updated or increment operation occurs. In case of prefix, first value gets updated and then whatever value is updated gets returned. So let's see here. So here what happens, x equal to x plus plus. So here first x gets the value as 5 and then we are incrementing x to 6. So what is happening here in this case is that, in this case, for this scenario, when you are doing x equal to x plus plus and you are using the value of x after this particular line or after this particular operation, so here if you would have done x plus plus or plus plus x does not matter, because eventually it's the value of x that is getting updated. But here what we are doing is we are doing y equal to x plus plus. So x is 6 here. So we assign the value of 6 to y. Y gets the value of 6 and then after this value is assigned to y, x gets incremented to 7. Hence, when we print x and y here, we get the value as 7 and 6. Now, coming here, again here, if I print x, I will get the value of x as 6 only, because this is an increment operator, prefix increment operator. And as I said before also, that in these cases, if you would use increment or if you would postfix or prefix, does not matter, the result of x is going to be x only. Why? Because here x is the value that is getting updated, right? So I am updating x here and using it here. So by the time x comes here, it is already updated. So in such scenarios, if you use x as postfix or prefix, does not matter. But here what happens, that now my value of x is 6. So here we are using increment. So what happens in increment is, first value is updated and then assigned. So first x gets incremented from 6 to 7 and then y gets the value as 7. Hence, when we print y and x here, we get both the values as 7. So this is the difference between prefix and postfix.